Practicing our light ray diagrams. First diagram, I want you to label what type of mirror it is. Since we have the object on the outside of the mirror, this is one that's curving outwards. This is a convex mirror, also called a diverging mirror. Rules for convex mirror: we have light ray going in parallel. It goes out as if it came from the focus point. So you're going to put your ruler up, line it up with the focus point and where the light ray hits the mirror, and we'll draw that light ray in. Second light ray, I'm using a different color so we don't get them mixed up. Light coming into the optical axis, bounces off at the same angle. A little trick to make the same angle: we're going to put the ruler up here and measure how tall your object is and go straight down, and we'll make a mark down here to show that same distance downward, and that way we know this angle is exactly the same. The angle of incidence equals the angle of reflection. The last one goes into point C, so match our ruler up with C, and that light ray comes up to the mirror and bounces off along the same path. And we can see these light rays do not converge. That means we're going to get a virtual image. That's the definition of a virtual image. They do not converge. We're going to trace these three light rays backwards with dotted lines, and right where the extensions converge is where our image is going to be. All of our images I want you to describe with the same three words. This one is smaller, it's upright, and it's virtual. Virtual means it's going to be behind the mirror, cannot be projected onto a card. Next one I drew backwards just to get used to doing different types of light rays. This is curved inwards, so this is a concave mirror. This one's called a converging mirror because it makes the light rays converge. First light ray goes in parallel, comes out through the focus point. Second light ray comes in through the focus point and out parallel. Third light ray goes in through C and bounces back along the same path. Now these three light rays do converge. That means we're going to get a real image. The light rays start at the top of the object, so the converging spot is the top of the image. And this image is going to be inverted. It's smaller. And it's real because this image is in front of the mirror where the rays are converging. Last one is also a concave mirror, converging mirror. When we move the object in different positions, we get a different type of image, and that's what we're studying here. So I'm going to start with the first light ray going in parallel again, and it goes out through the focus point. The second one is a little awkward. It's supposed to go in through the focus point, and since we're past the focus point, we're going to start at the focus point, draw through the top of the image up to the mirror. So this light ray is coming in through the focus point, and then it bounces out parallel. The last light ray has to go through C, so I'll line my ruler up with C, and I'm just going to go ahead and start it at C. It goes up to the mirror, bounces off the mirror, and goes back along the same path. Now you can see on this one that the light rays do not converge, so we are not getting a real image this time. When they don't converge, you're going to have to trace them backwards behind the mirror to make a virtual image. So there's each of the light rays will trace backwards, and where these extensions converge, that's where our image is going to be. Looking at this image, it is upright and larger, and this one is virtual because it's behind the mirror, not in front.